Hi, I'm Toby Tung, a research scholar with the Analytical Instrumentation Facility, or AIF, at NC State. Today we are preparing samples for transmission electron microscopy, or TEM. To do this, we'll visit Brianne Johnson, a graduate student in the Material Science and Engineering at NC State. She will show us how to conduct work in the sample preparation laboratory. Remember, electrons must pass through the sample to generate an image. So the samples in TEM must be very thin, less than 150 nanometers. Because we have to use such a thin sample and we only analyze a small part of it, we must make sure that this sample is truly representative. This can be done by sampling larger areas using other analytical tools like optical microscopy or scanning electron microscopy before we use TEM. To prepare samples from a bulk specimen, we can use various techniques like ion beam milling, ultramicronomy, and mechanical polishing. In each of these techniques, we remove material until it is thin enough for the microscope. Today we will be demonstrating mechanical polishing. Here the samples are polished to a predefined height that can be controlled by the instrument. We will use the multi-prep instrument to polish the sample. In this technique, the sample is put into contact with a piece of lapping film. A lapping film consists of a thin piece of plastic backing that has been coated with small particles of an abrasive material like diamond or silicon carbide. Lapping films are identified by grade, which describes the size of the abrasive particles. Today we will be using a diamond lapping film with a grade of 15 micron. First we load the platen, which is coated with the diamond lapping film. The diamond lapping film rotates in a circle just like a record player to remove material. The sample is placed in the sample holder. Today we will be polishing a sample of hafnium oxide. This material is often applied to other materials in a thin coat. It can act as an insulator. We enter the desired thickness of the sample into the micrometer. We begin rotation of the diamond lapping film and turn on the chilled water. During the polishing, the water will wash away the removed material and ensure the sample does not heat up. We bring the sample into contact with the diamond lapping film to start the polishing process. We monitor the thickness of the sample throughout the process using a micrometer. Once we reach the desired thickness, we stop polishing. Depending on the sample, multiple polishing steps and different grades of diamond lapping film may be required to reach the desired thickness. In addition, samples for TEM are often polished into a wedge shape. To make this wedge shape, the sample is brought into contact with the diamond lapping film at an angle. This can reduce the time required for sample preparation and makes handling samples much easier. The thicker part of the sample can be easily picked up and moved without damaging the thinner section, which will be imaged. After polishing, the sample can be made even thinner using ion milling. Here ions, or charged particles, are generated from an inert gas like argon. They are then accelerated toward the sample and physically remove material. The majority of samples must be mounted onto a TEM grid. This grid provides structural support to the sample and allows for easy and safe handling of samples. This grid is typically made of a metal like copper or molybdenum. The grid has pores of a specific size. Again, because in TEM, electrons must pass through the sample, the pores are critical to allowing this. The pores range in size from tens to thousands of microns. Grids are typically referred to by mesh size. The higher numbers indicate that there are more pores present, and these pores are smaller. A small mesh size signifies a larger pore size. In other words, fewer total pores. The sample is mounted to the grid with glue. The glue is applied around the edges of the sample to ensure that we do not image through the glue. Once the glue dries, the sample is cleaned with a plasma cleaner. This helps remove debris like dust or particles from the polishing process. After plasma cleaning, the sample is ready for imaging. If the sample is non-conductive, it may need to be coated with a conductive material like carbon. If we have a sample in solution, the sample preparation is even simpler. Samples are pipetted directly onto a TEM grid and allowed to dry overnight. Here we are pipetting gold nanoparticles onto the grid. Now the samples have been prepped, they are ready for imaging on the TEM.